NASA has released more photos from the world's most powerful telescope, revealing the deep secrets of space.
When the James Webb Space Telescope first opened its golden mirrors to the universe, scientists expected clearer images. What they didn't expect was a quiet revolution.
Give us a glimpse into the creation of the cosmos.
Almost immediately, Webb began showing us galaxies that didn't fit the story we'd been telling ourselves for decades. Not small corrections, not minor tweaks, but discoveries so unexpected that astronomers had to pause and ask a difficult question. Have we misunderstood how galaxies form and evolve? For a long time, the standard picture was comforting and orderly. After the Big Bang, the universe cooled. Gravity slowly pulled matter together, and over billions of years, tiny clumps grew into galaxies. The earliest galaxies were supposed to be small, messy, and faint, simple structures that gradually matured into the grand spirals and ellipticals we see today. It was a neat timeline. Webb shattered it almost overnight. When Webb looked deep into space, it also looked deep into time. Some of the galaxies it detected existed just a few 100 million years after the Big Bang. That alone was impressive. But what truly stunned scientists was how large, bright, and well-structured many of these galaxies already were. These weren't cosmic infants. They looked more like teenagers or even adults, appearing far earlier than theory said they should. It was as if you opened a history book expecting cave drawings and instead found skyscrapers. These galaxies contained billions of stars, formed at a pace that seemed almost reckless. According to previous models, there simply shouldn't have been enough time for gravity to do that much work. Yet Webb's data was clear. Either galaxies formed far faster than we believed, or something fundamental about the early universe is missing from our equations. And that wasn't the only surprise. As astronomers examined the light from these ancient galaxies, they noticed something else: chemical maturity. Heavy elements like oxygen, carbon, and nitrogen were already present in significant amounts. Those elements are forged inside stars and spread through supernova explosions. Their presence means multiple generations of stars had already lived and died in what should have been the universe's earliest days. That discovery quietly rewrote another assumption. The early universe wasn't just forming stars, it was recycling them, feeding galaxies far faster than expected. The cosmos, it seemed, grew up in a hurry. Then came the black holes. Webb began detecting evidence of supermassive black holes at the centers of these young galaxies, enormous objects, millions or even billions times the mass of the Sun, already fully formed when the universe was less than 1 billion years old. Under previous theories, black holes needed long stretches of time to grow, feeding slowly on surrounding matter. Webb showed us black holes that had somehow skipped the waiting period. Scientists were left staring at the data, asking how such giants could exist so early. Some proposed new ideas: direct collapse black holes, exotic early conditions, or unknown physics that allowed matter to collapse far more efficiently. Whatever the explanation, one thing was clear: black holes and galaxies were growing together in ways we didn't anticipate. Webb also revealed that early galaxies weren't all chaotic blobs. Some already showed signs of organized rotation, disks, and structure. That was deeply unsettling to long-standing models, which predicted disorder first and elegance much later. Instead, Webb suggested that order may have emerged surprisingly quickly, almost as if the universe knew what it was building from the start. But Webb didn't just change our view of ancient galaxies, it transformed how we see galaxies today. When Webb examined nearby galaxies in infrared light, it pierced through dust that once hid entire regions from view. Suddenly, astronomers could see stellar nurseries buried deep inside galactic arms, places where stars were being born in violent, brilliant bursts. Entire regions once thought inactive were revealed to be alive with star formation. Galaxies that seemed calm and settled turned out to be dynamic, turbulent systems, constantly reshaping themselves. Webb showed us that galaxies are not static islands in space. They breathe, they collide, they cannibalize smaller neighbors, they grow through chaos. Even the way galaxies interact with their environments came into sharper focus. Webb observed streams of gas flowing into galaxies, fueling star formation, and powerful outflows blasting material back into space. This balance between feeding and expelling matter appears to regulate how galaxies live and die. It's less like a simple growth curve and more like a heartbeat. Another quiet revelation came from Webb's ability to measure galactic mass more accurately. In some cases, galaxies appeared far more massive than expected for their age. In others, they seemed oddly deficient in dark matter. These findings stirred debate because dark matter is supposed to be the invisible scaffolding holding galaxies together. If some galaxies formed with less dark matter or distributed it differently, it could mean our understanding of dark matter itself needs revision. And Webb didn't answer that question, but it made it impossible to ignore. Perhaps one of the most human moments in this unfolding story is how scientists reacted. Many openly admitted surprise. Some said they felt uncomfortable. Others joked that Webb was breaking cosmology. That discomfort is important. It's what real discovery looks like. Science doesn't advance when data politely confirms expectations. It advances when reality refuses to cooperate. Webb has reminded us how limited our perspective once was. Hubble gave us glimpses, beautiful, revolutionary glimpses, but Webb gives us context. It doesn't just show galaxies, it shows how they change, how they grow, and how they influence everything around them. It has turned galaxies from distant objects into evolving characters in a much larger story. And that story is still unfolding. With every new dataset, astronomers are refining models, discarding old assumptions, and building new frameworks. Some ideas will survive, others will quietly disappear. That's the price of progress. What's remarkable is how quickly this transformation happened. Webb has only been operating for a short time, yet it has already forced rewrites of textbooks and lecture slides around the world. Entire careers are now pivoting to understand results no one predicted. And perhaps the most profound shift is philosophical. For decades, we viewed the early universe as simple, primitive, and slow. Webb paints a different picture, a universe that was ambitious, creative, and surprisingly efficient. Galaxies didn't timidly emerge, they erupted into existence, blazing with stars, structure, and complexity almost immediately. It's a humbling realization. The universe didn't wait for billions of years to become interesting. It was interesting almost from the beginning. As Webb continues its mission, the surprises are unlikely to stop. It will probe even earlier epochs, fainter galaxies, and deeper cosmic structures. It will test ideas about dark energy, galactic feedback, and cosmic evolution at a level we've never reached before. But even now, one thing is already certain. The James Webb Space Telescope didn't just sharpen our view of galaxies, it changed the story we tell about how the universe grew up. And in doing so, it reminded us of something deeply human. Every time we think we finally understand the cosmos, it finds a new way to surprise us.